Okay, in today's lesson, we're going to continue talking about transformations, but today we're focused on the non-rigid ones, the ones that are going to stretch and shrink it, okay? So relative to just a general function f of x. Now, remember c here is just a constant. That just means any number. So I'm going to use a basic function for f of x, just for example's sake, I'm going to use y equals x squared, okay? And I'm going to use any number c that meets the criteria here. So g of x is c of f of x is a vertical stretch if c is greater than 1. So that would look like this. Y equals 2x squared. C right here is greater than 1. It's a stretch. That means it's getting taller and skinnier, okay? It's getting skinnier. So this is originally like a parabola, right? It's getting taller and skinnier. Okay, we're just going to go down the left side because everything here on the left of our notes is vertical changes. Okay? Vertical changing, all right? Vertically what's happening. On the right is going to be horizontal. We'll get there in a moment. This is a vertical stretch. Now notice what happens if that c is between a 0 and 1. So what does that mean? That means a fraction or a decimal, right? That means it's going to shrink. So my original quadratic is going to get fatter, flatter and fatter. So for instance, if I did y equals 1/4 x squared, that is a vertical shrink. Notice the 1/4 is outside the x squared. It's in the very front. Now it says compare the graphs with each of the graphs. So if the parent function was the absolute value of x, what is this 3 doing? Well, that's a vertical stretch by 3. So you want to tell me how much it's stretching, okay? Let's come back to the top right part of our notes and let's focus on horizontal stretching and horizontal shrinking. So look, a horizontal stretch happens if c is between 0 and 1. So this is a fraction. This is that fraction thing, right? But look, it's a stretch. So it's opposite logic when we get to horizontal. It's always opposite logic. So my function, let's say I was going to horizontally stretch this thing. So it would be y equals 1/2 x squared. Notice that the c value is between 0 and 1. It's a fraction. And it's inside the parentheses. That's what makes it horizontal. And it's opposite logic. If it's a fraction, it's going to stretch. So if it's going to shrink, it has to be greater than 1. So it would be 2x squared. That would be a horizontal shrink. This would be a horizontal stretch. It's opposite what you would think, but that's the way it is. Always everything horizontal. Remember how the left and right thing is backwards? So is the shrinking and stretching. So let's look at this one. Compare the graph of each with the graph of the original. Okay, so if this is my quadratic, what's happening here? Well, that's on the outside, so this is a vertical stretch by 4. This is back to what we were doing on the left side. All right, so let's do this one over here on B on the left side. G of x is 1/3 absolute value of x. So that 1/3 is on the outside, so that means it's vertical. It's a vertical and it's a fraction, so it's a shrink by 1/3. Look at part C. The 3 is on the inside, so that makes it a horizontal, and it's opposite what you think. That 3 means a shrink by 1/3. So it's always shrinking by the reciprocal. So the horizontal is always going to be opposite when you write it out. When you describe it in words, you're always going to write the reciprocal of what's in the equation. So for instance, this 1/3 is in here again. So this is a horizontal stretch by, what's the reciprocal of 1/3? It's 3. So be really careful when you describe horizontals. You want to use the reciprocal value. All right, let's come over here and look at this one, the quadratic. What's happening to our original quadratic? Well, that 1/4 is on the outside, so it's a vertical, it's a fraction, so it's a shrink by, just like it looks, by 1/4. But this 1/4 is on the inside, so it makes it horizontal, and it's opposite logic, so it's not a shrink, it's a stretch, and stretches get bigger, so it's by 4, it's the reciprocal. And look at this one. This 4 is on the inside, so it's horizontal, opposite logic, so it's going to be a shrink When you shrink, you go by fractions, so by 1/4. So remember, take the reciprocal. All right, compare the graph of each function with the graph of f of x equals square root of x. So this is the starting point. And also use function notation to write each function in terms of the parent function. So let's stop and think. If this is g of x is negative square root of x, how is that different than the original? Well, it is a vertical reflection, or if you wanted to say reflects over the x-axis, that is fine as well. Either description is fine. Now to put this in function notation, you're going to tell me that g of x is equal to, notice it's just the reflection, so it's negative in the front of f of x. That's how you rewrite it in the terms of the parent function. Let's try the next one. This one, notice this is a horizontal reflection, or the negative's on the inside, that's how I know that. Or you could say it reflects over the y-axis. Now, to put this back in f of x notation, it's saying h of x is now f of a negative x. The negative has to go on the inside of the parentheses to remain horizontal. K of x, look at this, what's happening here? Well, that's a vertical reflection. And the +2 means it's going to move left 2. So to put this in function notation back in terms of f of x, I need that negative to be on the outside, but what's happening to the x on the inside? It's x plus 2. Notice the square root's gone because there's somewhere telling us that f of x is the parent function. So we don't have to include the square root because it's understood by using the f of x term in this question. Okay? It's a little weird, but you can do it. Now, look at some other examples here. Graph the three functions in the same window. Describe the graphs of g and h relative to the graph of f. All right, so let's look at this. What is happening here? The original function is x to the third minus x squared. What's happening here at g of x? It's taking that original f function and adding 2. So what is that going to do to my function? That is just moving it. All I want you to know is that it's moving it left 2 units, okay? Just left 2 units. So what would that mean if I had to graph that? That would just mean I would say, look at the original function and plug in x plus 2 where there's an x squared. You can graph these on your calculator if you'd like, but really what I'm concerned about is that you noticing the change from the equation. All right, and h of x, what's happening here? There's the original. What is that 1/2 doing? Well, that's a vertical shrink by 1/2. So if I had to write it out, what's that going to do? It's 1/2 times x cubed minus 3x squared. That's really all it's doing. What's that going to do? It's going to vertically shrink it by 1/2. That is really the part I need you to know. I'm not too worried about you graphing it right now, okay? So you don't have to mess with this. Example 2. Here's my original. It looks the same, doesn't it? Look at this one. The negative 1/3 is on the outside. What is that negative 1/3 doing? Well, that negative 1/3 is there's two things going on. It's a vertical reflection, the negative. The 1/3 is a vertical shrink by 1/3, right? That is what I need you to see is how it's changing the original function, just those two things. Now this one, how's that 4 inside doing it? Well, remember that's horizontal. If it's inside and it's opposite what you think, if it's a 4, it's actually shrinking by the reciprocal, by 1/4, okay? Graph it on your calculator so you can see it. If you needed to put that in your calculator, you would just put in 4x to the third minus 3 times 4x squared. That would be what you put in to see the difference, okay? All All right, example 3, it says g is related to a parent function. A, identify the parent function, describe the sequence of transformations to g, and then sketch the graph. And then D, use function notation to write g in terms of the parent function. So let's do it step by step. A says, identify the parent function. Well, notice this one, it has an x squared. So the parent function is y equals x squared. B, describe the sequence of transformations. So let's see what's going on here. The x minus 4 means it's going right 4. Remember that you could put this plus 3 on the back side. It might be able to help you see what's happening there. That one's moving up 3. What is the 2? That's a vertical by 3. Part C says to graph by hand. Okay, so I'm taking what used to be at the origin at 0, 0, and I'm going to move it right 4 units. And we'll move it up 3, 1, 2, 3. And a vertical stretch of 3. Now, this is quadratic, so I'm not going to worry too much about your points, but you just need to show me that it's skinnier than normal, okay? Skinnier than normal, that's what I'm going for. Now, that's part C, right? D says to use function notation to write g in terms of the parent function. So g of x is what's happening to my parent function. There's a lot going on here. All right, look at number 4 here. Let's see. G of x equals x minus 1 cubed plus 2. All right, let's look at that. That's going to be our cubic function. So part A, y equals x cubed. Part B, we're going to list what's happening. Well, the minus 1 means it's going to move right 1. Plus 2 means it's moving up 2. All right, on part C, we're going to graph that cubic function. So it started at 0, 0, but it's going to go right 1 and up 2. All right, so there's my new cubic function. It moved on me. That's part C. D, they wanted us to write it in terms of the original function. So it's going to be f of x minus 1. We don't need the cubed anymore because we know it's cubic. And then the plus 2 out here. Look at number 5. What parent function goes with this? Well, that's y equals the absolute value of x. Let's list our transformations. There's a lot happening. That negative out front is a vertical reflection. The 2 is a vertical stretch by 2. The minus 1 means it's going to go right 1. And the minus 4 is going to go down 4. Okay, so absolute value is a v, right? So let's move my vertex right 1, down 4. And the vertical stretch by 2 just means a slope of 2. So you're going to go down 2 over 1, down 2 over 1, but you go in both directions because it's a v. So it looks like that, little skinny v. And then lastly, let's do g of x. G of x is negative 2, f of x minus 1 minus 4. So we don't need the absolute value bars because we know f of x is absolute value. All right? Hopefully this is making some sense to you, and let me know what questions you have when you get to class. Good luck.